You may recall how in the previous tutorial we learned how to use brush-based tools to modify the layer directly. Here I will show you how to use masks, effects, and blending modes to combine layers together, and why modifying single layers directly is not the easiest way to make an image. A mask is very easy to create for a layer. All you have to do is right-click and then click Add Layer Mask. On Photoshop, the mask will always start out as fully white. But on GIMP, you are given a handful of options to preset the mask to do most of your work for you. However, for the purpose of this tutorial, I decided to stick with full white, so that way you can see the process of making a mask in action. A mask works by blending the layer with all the layers beneath it, according to a transparency map. Every color on the map is automatically turned grayscale, with white being fully opaque and black being fully transparent. Like so, notice that the full white means that it is covering the layer beneath it right now, but as you apply a solid black brush, the layer beneath it will appear. Similarly, if you have a grayish area, it will attempt to merge the two layers transparently. Layer masks are very useful if you want to blend two layers smoothly, without the tedium of using the clone or healing tools to try to simulate it. The blending mode combines the layer with all the layers beneath it, according to a bunch of preset options rather than a grayscale map. In particular, the modes can be categorized as either solid blending, darkness-based blending, lightness-based blending, or hue-based blending. The two solid blending options are normal, which is the default and does no blending whatsoever, and dissolve, which randomly replaces the pixels to make it look like the two layers are dissolving into each other. Note that if it is fully opaque, no dissolving gets done. It has to be at least some transparency for the effect to happen. The darkness-based options are darken, which completely replaces all lighting greater than 50%, multiply, which multiplies all the layers by the darkness value of each layer regardless of how light it is, color burn, which increases the difference between colors, aka contrast, between all the pixels on each layer for a burned effect, and linear burn, which decreases the brightness in a uniform fashion as opposed to the color burn. The lightness-based options are almost all the exact opposite of the darkness-based options, in the sense they function the same exact way, but replace the image's lightness rather than darkness. In particular, the counterpart to darken is lighten. Screen is the opposite of multiply. Color burn is the opposite to color dodge. And linear burn and dodge are opposites. However, in GIMP, linear dodge is instead called addition. However, there are lightness-based options that are not exact counterparts to dark-based options. In particular, overlay preserves the shadows and highlights of the first layer while partially displaying everything beneath it. Soft, hard, and vivid lights do the same thing, just with different degrees of intensity. Linear light works by changing the lighting in the first layer by using all the layers beneath it as reference points. Pin light works by replacing the lighting by a flat amount rather than adding all the layers together. The final category, hue-based blending, replaces layers by color rather than by lighting. Hard mix works by adding all the RGB values of all the layers together. And if any of the RGB value results are less than 255, they automatically become 0. This means that every color is either fully bright or fully dark. There is no in-betweens. Difference looks at the greater RGB values and subtracts the lower ones. Exclusion is similar, but more mild, so the contrast is lower. And subtract will always subtract according to the list of the layers rather than comparing the values. Divide is similar to difference, but instead of subtracting the lesser value from the greater one, it divides them instead. Hue blends only the hue value and does not touch saturation or luminosity. Saturation and luminosity do the same thing for their respective components. Color blends both hue and saturation. Finally, lighter color and darker color replace the lighter and darker colors respectively and by a hard amount rather than blending them the way the other options do. In GIMP, all of the above options except for a lighter color and darker color, the last ones mentioned, exist. And there are also a handful of tools unique to GIMP that are not options in Photoshop. Color Erase erases areas with similar colors, like so. Erase erases areas with similar lighting values, such as the two gradients in this image. Merge just seems to do the same thing as if you selected normal, and split appears to do the same thing as if you selected erase. In the lightness-based options, luminance lighten only acts very similar to lighten, but as is suggested in the title, only lightens by the lighting values, ignoring hue and saturation. Luminance darken only does the same exact thing, but in opposite. Grain extract subtracts the upper values from the lower values, and then adds 128 for each pixel. Grain merge, as predicted, does the exact opposite. The hue, saturation, and color blending options are split into HSV and LCH columns. HSV stands for hue, saturation, and value. Value is essentially lightness plus saturation. LCH stands for lightness, chroma, and hue, We generally do not work with chroma in digital graphics, so we will not stress about what it means too much. If you are curious, however, chroma is a very similar concept to saturation. Although the list of blending options is very extensive and can feel overwhelming at first, it becomes very handy and convenient to use once you get used to it. Now that we have gone over how blending modes work, we are able to use these to more fully understand how layer effects work. In Photoshop, layer effects are provided by a small icon with a larger F next to a smaller X that provides a pop-up menu when you click on it. The particular layer effects list you will see is Drop Shadow, which adds a shadow behind the layer, Inner Shadow, which adds a shadow on the inner edges of the layer for a sunken look, Outer Glow and Inner Glow, which adds a glow around the outer and inner edges of the layer respectively, Satin, which adds a texture to the layer for a satiny look, Color, Gradient, and Pattern Overlay options, which replace the layer completely with either a solid color, a gradient, or a pattern respectively, and Stroke, which does a similar thing but only applies to the edges of the shape for a cartoony ink stroke look. Notice how all the effects are very customizable and also have a graph shape option, which is called a contour. We will touch on contours more in depth later, but for now we will focus on the more basic customization options. In particular, the options are Altitude, which determines the light source for a bevel or embossed. In general, the greater the altitude, the more pronounced the effects there will be. Angle, which determines the lighting angle of an effect. Anti-alias, which blends the edges smoothly instead of making it look hard and pixelated. Blend mode, which works the same way as discussed earlier, just applies to the layer effect rather than the whole layer. Choke, which shrinks the edges of inner glows and inner shadows. Color, which determines the color of a shadow, glow, or highlight. Distance, which determines how far away a shadow is from the layer, or the offset distance of a satin texture. Depth, which works only for bevels and patterns. Use global light, which means that you will have one lighting effect for them all instead of having individual lighting effects for each effect. Gradient, which allows you to customize a gradient as shown in the third video if you wish to apply a gradient to the layer effect. Highlight and shadow modes, which affect only the highlight and shadow blending and nothing else in the layer effect. Jitter, which makes the color and opacity of a gradient more random than smooth. Layer knocks out drop shadow, which means that a semi-transparent layer will completely block the shadow rather than showing it. Noise, which will add random pixels to a shadow or glow rather than making it completely smooth. Opacity, which works the same exact way as a normal layer, except it only applies to the effect in question. Pattern, which allows you to load a preset pattern and apply it to the shape. Position, which only works for the stroke effect and allows you to determine whether the stroke is outside the shape, inside the shape, or in the center between the outside and inside. Range, which determines the range of lighting a contour will affect for a glow. Size, which determines the radius of either a blur or a shadow. Soften, which blurs the shading such as shadows or glows in order to make it not have artifacts that you can clearly see. Source, which only determines the source for an inner glow. Center means the center of the layer, while edge means inner edges of the layer. Spread, which spreads out the layer effect a little bit further. Style, which only works for bevel and embossing, and in particular are an inner bevel for the inner edges of a layer, outer bevel for the outer edges of a layer. Emboss. Pillow emboss, which stamps only the edges into the layers underneath. And stroke emboss, which only embosses the stroke. Note that if you have no stroke effect, nothing happens. Technique, which is smooth, chisel hard, and chisel soft for the bevel and emboss, and softer and precise for the inner and outer glow effects. For the bevel and emboss, smooth is the smoothest but least accurate. Chisel soft is still soft but slightly more accurate, and chisel hard is the most accurate, at the expense of having a lot of unwanted artifacts and hard pixels. Likewise, for the two glow effects, softer is softer, but precise is more accurate, but gives you more unwanted artifacts. And texture, which is mostly only used for the satin effect. As you can determine, the texture determines the pattern that the satin effect uses as a reference. Now that we have gone over the most basic options, we can now move on to contours. A contour uses a mathematical function to determine the lighting of the effect the contour is applied to. For example, a linear contour causes the opacity to drop off in a very linear fashion. Like with gradients and brushes, you can either create your own custom contour or load one from online. In particular, the file extension for custom contours is SHC. To create your own custom contour, you simply have to click on the contour in the layer effects if your layer effect has a contour. Once you click on the contour, you can click and drag to add points. Note that it will attempt to smoothly connect the points for you. If you want a sharp corner instead of a smooth curve, however, click on one of the points and then click Corner. Once you are satisfied with your contour design, you can click Save and you will be prompted to name your contour before saving it. One option I did not go over earlier because it involved the use of contours was Gloss Contour, which basically sets a metallic or glossy look in accordance with the contour pattern you have given it. Note that there is also an anti-aliasing feature to smoothly blend the edges of a contour. Although that is everything you need to know for the layer effects in Photoshop, GIMP is entirely different and refers to its layer effects as filters because they work slightly differently. In particular, most of these filters affect the whole image rather than the layer, and you also do not have contours to customize them, although they still allow you to customize them in different ways. Because of how many there are, the filters are divided into categories instead of being in one menu. In particular, the groups are Blur, Enhance, Distort, Light and Shadow, which affects lighting, Noise, which generates randomly colored pixels, Edge Detect, which attempts to isolate and detect only the edges of an image, Generic, which are the most basic filters and are not as specific as all the rest, Combine, which combines multiple images together, Artistic, which attempts to simulate famous artistic methods, Decor, which adds basic decorations to the image, Map, which affects the image according to a map, much in the same way we used transparency maps earlier. Rendering, which renders a complex image on top of the existing image. Web, which is mostly used to optimize your image for websites. And finally, animation, which attempts to animate a still image in multiple ways. Now that we have gone over all of the basic categories of the filters, we can go over each filter one by one. The Gaussian blur is the most basic blur and attempts to blur the whole image at once. Like so. Size X and size Y determine the horizontal and vertical blurring. Filter is best left at automatic for best results because it can tell the type of image and filter it needs to use for you. Abyss policy is a fancy way of telling it how to treat the edges. And clip to the input extent clips unnecessary pixels added by the filter on the edges. Finally, the clipping drop-down menu determines whether it should adjust to the clipping to try to fit as best as it can, or clip to make a hard absolute clip. Finally, the preview option is not unique to Gaussian blur. It applies to basically all the filters. What it does is it allows you to show you the filter before you apply it, and split view attempts to show you half of the image as it exists and half of the preview if you check that. The mean curvature blur attempts to find the average curvature, or how curved each part of the image is. It then attempts to blur the areas in this method so that something that is more pronounced in curvature or more pronounced in straightness, i.e. greater the distance from the average, becomes more blurred. Increasing the iterations increases the amount of times it does this, so more iterations means the blurring is more intense. The median blur functions very similar to the Gaussian blur, but also prompts you for a neighbor area like the select tool does. And as its name suggests, blurs more of the middle areas rather than averaging all of the areas to blur. The greater the percentile, the more sensitive it is. And the greater the alpha percentile, the more sensitive it is to transparent areas. Pixelize converts all of your smooth images to pixel images. Like so, and allows you to determine whether you want to do it by a square pixel, a diamond pixel, or a round pixel. As you may be able to guess, block width and block height determine how wide and high each respective pixel is. Offset X and offset Y determine how far apart the image is moved from the origin on the X and Y axes respectively. Size ratio determines the ratio of space between the pixels on the X and Y axes. One is right next to each other, while anything lower will make the pixels more spaced out, with the layer beneath it showing. However, because pixelate applies to the entire image rather than just a layer, the layer beneath it is nothing more than an empty blank background. You can specify the color of this background using a color picker. Selective Gaussian blur is like the regular Gaussian blur, except that you can limit it to a specific radius and only affect a specific layer or channel of the image. You can also determine the max delta, which determines how quickly the blurring spreads out, aka how intense the blurring is. Circular motion blur attempts to blur in a circle pattern to make the image look like it is spinning around. Center X and center Y determine the X and Y point for the reference of rotation, and angle determines the angle of rotation. The greater the angle, the more intense it is. You may notice a new option called On-Canvas Controls, which gives you a guide to allow you to see the center of reference. Linear motion blur attempts to make the image look like it is moving in a linear direction. Length determines the intensity of the blurring, and angle determines the direction of the blurring. Like so. Zoom motion blur makes it look like you are running straight at the image, with center X and center Y determining the focal point of the blurring, and the blurring factor determining how intense the blurring is. Like so. Finally, tileable blur, as the name might suggest, makes a grid of multiple blurs, like tiles, with radius determining the size of each tile, blur vertically determining whether the blurs will be distributed in columns, and blur horizontally determining whether the blurs will be distributed in rows. If you have it in both, it'll be distributed diagonally across both rows and columns. Sadly, the tileable blur does not have an automatic feature. So it is important to note that IIR is mostly used for photographs the way JPEGs are, and that RLE is mostly used for cartoons and similar drawings the way PNGs are. It also does not allow you to preview, mostly because the script is so complicated that it would take a long time simply to load the preview before rendering it. Now that we have finished all the blur tools, we can move on to the enhance tools. Fortunately, Most of the enhance tools are much more simpler than the blur tools. The first enhance features anti-alias, which softens hard edges across the entire image, rather than the way it worked in a contour. Like so. Notice that the hard white is now more softer in the A. The deinterlace feature attempts to fill in missing lines on an image by applying a gradient between the previous and following lines. You can tell it whether to not affect even versus odd fields, whether to fill in the gradient horizontally or vertically, and the size of each block to check and apply the gradient to. Note that the larger the block, the more pronounced the gradients will be, making a blurry effect. Like so. The high-pass filter passes higher frequencies, which in graphics refers to the changes in lighting between pixels. This means that more subtle changes in color or brightness will be discarded. Increasing the standard deviation means that the filter has a lower threshold and affects more pixels, and the contrast determines the contrast of the image after it has been filtered. Like so. The noise removal filter attempts to find areas that have random pixels, aka noise, and try to remove them. The greater the strength, the more sensitive it will be, but the trade-off is the more blurry it will be. Like so. The perspective filter, the filter after that, makes a drop shadow, but with a 3D twist. The angle determines the angle or direction of the shadow. The length of distance horizon makes the shadow more stretched out, while the length of shadow does not so much stretch it to a single point as it does scale the shadow. The blur radius, color, and opacity work the same as in a regular drop shadow, and interpolation will determine the method for anti-aliasing the edges of the shadow. As mentioned in other filters, there is no really huge difference in interpolation methods, so you can choose any one you want, although none will make the edges hard. Finally, there is a check mark for allow resizing, which will resize the image to fit the shadow, but if you don't check this, it will only use the size of the image you currently have. The last lighting and darkening filter is the Zatch effect, which creates a translucent effect to the image. This filter will create an extra layer on top of the layer you are applying it to, which is a highlight rectangle with a layer mask on it for the translucent effect. The Zatch effect also adds a drop shadow to the region. The highlight size of the X and Y dimensions determine the width and height of the highlights. Negative offsets for X and Y mean the left and top areas are colored more respectively, and the inverse is true for the positive offsets. The highlight color determines the color of the highlight, white being the default. The highlight opacity determines the opacity of the highlight. The rest of the options affecting the drop shadow work exactly the same way as the default drop-down filter. The next set of filters are the noise filters. The first of these is the ICE-LCH filter, which creates noise by using lightness, chroma, and hue variations. The dulling slider makes the noise less intense the greater the slider. The lightness slider determines the overall lightness of the pattern. The chroma slider changes the chroma and the noise patterns. The hue slider changes the amount of hues the pattern will show. And the random seed will determine how the noise is distributed each time. Like so. The next filter option, HSV noise, uses hue, saturation, and value to determine how the noise looks. Although the dulling feature works in a very similar one to the previous one, the hue slider works here instead by making the image less saturated the greater the hue. The saturation slider determines the difference in saturation between each pixel in the pattern, and the value slider does the same thing, except for the value component. Like so. Also, like the last noise filter, the random seed will distribute the noise randomly each time. The next filter option, Hurl, uses truly random colors that are not determined by referencing the image you are applying it to. The randomization slider will determine how much random colors there are applied. The repeat slider determines how many times the pattern is repeated across the image, although a greater randomization does the job just as well. Like so. Yet again, the seed changes how it is randomly distributed each time. The next filter is the pick filter, which, as its name suggests, picks each pixel in a 3x3 area, so a 9 square grid, and replaces them randomly with each other. This can be used to create a very nice runny effect. The randomness slider determines how much pixels will be selected, and the repeat slider will determine how much iterations of the noise is applied across the entire image, the same way it works in Hurl. Finally, it uses the same random seed to distribute the noise the way it does for all the other noise generators. like so. The next filter, RGB noise, works by adding a normally distributed noise pattern to the end. Normally distributed means that the middle areas are more affected, while the more extreme areas are less affected. As its name suggests, the filter applies red, green, and blue concentrations, as well as an alpha concentration to alpha channel images. The correlated noise checkbox multiplies each noise value by a normal distribution. The independent RGB checkbox allows you to move the red, green, and blue concentrations independently. If you uncheck this option, it will be condensed into only one value slider. Linearized RGB makes the channels add up in a linear amount, and Gaussian distribution determines whether the distribution method is Gaussian, aka uses a normal curve, or is linear. The last option is random seed, which works the exact same way as the other noise options. Like so. The next noise option, slur, samples the pixels from above, or sometimes the pixels next to the pixels above each pixel, to make it look like the image is melting downwards. As with the hurl feature, randomness determines how much sampling is done, and repeat determines how often the sampling is done. Finally, as always, the random seed determines the distribution of the noise. Like so. The last noise option, spread, replaces neighboring pixels with each other to create a spread out transition. However, unlike all of the other filters, spread adds no new colors, it only transitions existing colors. The horizontal slider determines how much noise should be applied horizontally, and the vertical slider determines how much noise should be applied vertically. Finally, the random seed changes the distribution just like all the other noise patterns. Like so. Now that we have gone over all of the noise filters, we may now proceed to the edge detect filters. The first filter is the difference of Gaussians, which applies two Gaussian blurs to the image and subtracts them to isolate the edge. The general rule of thumb is that increasing radii 1 will give you thicker edges, while increasing radii 2 will give you a lower threshold for what counts as an edge. Like so. The next filter is a widely customizable edge detector filter. The algorithm options are Sobel, pre-wit compass, which has no noticeable difference, gradient, with thinner, less contrasted and more blurrier edges than Sobel, Roberts, with no evident difference from Sobel, differential, with the edges less bright than Sobel, and Laplace, which is its own algorithm and is very different from Sobel. The greater the amount, the thicker the edges. However, the contrast decreases with the amount. Border behavior determines what happens around the border of the edges, although we generally leave it at clamp for best results. This is the edge detector in action. Sobel, pre-wet, gradient, Roberts, differential, Laplace, increasing the amount, going back to Sobel with increased amount. The next filter is Laplace, which was already integrated in the previous filter. This one does not allow you to specify any amount. Like so. The next filter, Neon, is similar, but applies a neon lighting effect to the edges, like an actual neon sign. The radius determines how large the lighting is, and intensity determines how bright the lighting is. Like so. The next filter, Sobel, has also been condensed to the edge select filter shown earlier, but this one offers options to select it by horizontal slices or vertical slices. And the keep sign checkbox will create extra bumps and hollows for you. Like so. The next filter option, Image Gradient, works by using a gradient to detect the edges. The default option, Magnitude, detects gradients in both directions, while the Direction option detects in only one of them. The filter will determine exactly what direction for you, though you are not allowed to customize it. The last option, Both, is the exact same thing as Magnitude. Like so. The final edge detect filter is the legacy version of the difference of Gaussians. It has the same options as the original, plus normalize, which makes the edges more pronounced, and invert, which inverts the colors. We will not be using the generic filters because they are far too finicky, and we will not be using the combined filters because we do not generally work with multiple images that would need combined filters in game design. However, we can proceed to the artistic filters. The direction controls the corner the canvas starts from and moves away from, and the depth controls how thick the canvas appears, with lower amounts being very flat and bigger amounts being very thick. Like so. The cartoon filter makes dark edges darker to make it look like it has thick cartoon lines, with the mask radius determining how wide or thick the cartoon effect is, and %black determining how pronounced the cartoon effect is. Like so. The cubism filter divides the image into small squares scattered diagonally. The tile size determines how large each square is. The tile saturation determines how saturated each square is. The background color determines the color of the area the squares do not reach. And the seed, like with the noise filters, determines the distribution pattern of the squares. The next filter, glass tile, repeats part of an image as if it were reflected through glass tiling. The tile width determines how far apart horizontally each tile is, and tile height determines how far apart vertically each tile is. The next filter after glass tile is oilify, which makes your image look like it is an oil painting. The two auxiliary inputs allow you to specify layers or channels to limit the oil painting to effect. The default option with none on both means the entire image will be affected. Mask radius determines the size of the oil brush. The greater the mask radius, the more runny looking and less accurate the image will be. Exponent is used to determine how dense the oil brush is or how hard it will push. Intensities determines the range of lighting the oiling will affect. The lower this number, the less accurate it will be because the less lighting will be affected. The intensity mode checkbox determines whether to use the luminance values provided or not, like so. The next filter, photocopy, detects very dark images and makes them black, and makes the rest of the image white. The mask radius determines the radius of sampling to check if something is dark enough to be black or not. Sharpness determines how sharp the photocopy looks. %black makes any parts where the black is applied thicker, and %white makes all the areas that are white more intense. like so. The next filter is simple linear iterative cluttering, which uses superpixels, aka large groups of similar pixels, to pastelize the image. The greater the region size, the greater the superpixels or pixel groups, whatever you wish to refer to them as. The greater the compactness, the more regular the borders will become, or the more even they will be, and not as random. And increasing the iterations increases the amount of times the filter is applied. The more iterations, the more details we'll be able to get. Like so. The next filter, soft glow, makes bright areas brighter, so it creates a soft glowing image across the entire area. The glow radius determines the radius size around the brightest areas. The brightness determines how intense the glowing is, and the sharpening determines how sharp the glowing is. Like so. The next filter, water pixels, again uses superpixels to make the image have a very watery look. The superpixel size determines the size of each pixel group. Gradient smoothness determines how smooth the color transitions are. Spatial regularization determines how pixelated the overall pattern will look like. And superpixels color will allow you to average all the pixels within the group or determine a random color for each group. Like so. The red eye removal filter, as suggested by its title, is mostly only used to remove red eyes from photos. However, you can use it to filter out red colors in any image. At the default threshold setting it has, it will only select bright red colors such as the inside of the A's in this image. But if you decrease this threshold, the filtering will not be as intense. And if you increase the threshold, it will filter out the red out of any pixel, not just the bright red parts. Like so. The symmetric nearest neighbor filter compares each pixel to its nearest neighbor, in addition to one or two pairs of symmetrically identical pixels, also nearby the first pixel. You can determine whether to do one or two pairs, but no less and no more. And you can also determine the radius, which is the area that it will compare and filter. Like so. The sharpen filter uses a radius starting at the edges to sharpen the image. The radius determines how far away from the edge you want to go. The amount determines the intensity of the sharpening. And the threshold determines the difference in pixels you need in order for the sharpening to detect and apply. The greater the threshold, the less things affected there will be. Like so. The despeckle feature attempts to remove specks in an image. You may notice the adaptive and recursive checkboxes underneath the word median. Adaptive attempts to adapt around the frequencies of an image, while recursive repeats the filter across the whole image, ignoring changes in frequency. Note that you can have both options on at the same time. The radius determines the size of the area it checks. The black level determines the darkest or minimum frequency, and the white level determines the maximum or brightest frequency. Like so. The D-stripe feature attempts to apply a filter to remove stripes by referencing the vertical parts of an image. If you check Create Histogram, it will give you a grayscale image on top, indicating the light map, aka how the lighting is distributed on the image. The greater the width, the more stripes it will check for. Like so. Notice that if you do not have stripes in the image, it will add them. The NL filter, or non-linear filter for short, uses hexagon sample radiuses rather than square or pixel ones. It combines multiple of the filters we have examined earlier to have its own unique effect. The alpha slider determines the amount of the filter to apply, and the radius determines the size of the area. Because of how complicated this filter is, it has multiple operating modes under the Filter drop-down menu. The alpha trim mean option will replace the center hexagon with the mean of all the 7 hexagons around it. These 7 values are sorted by their size, and the alpha value of the top and bottom are excluded. The optimal estimation filter attempts to smooth the colors. With the greater the variation or change between the colors, the less the smoothing there will be. The edge enhancements feature works like the smoothing feature, except in the opposite direction. Instead of smoothing, aka blurring, it enhances or sharpens it. However, the nonlinear filter will not work if you have an alpha channel, like this image does. Therefore, I will not be able to demonstrate it with this image. The final enhanced feature is the wavelet decompose, which divides the image into scales, which are ways of referring to it as layers of different detail. As a general rule, the more scales you have, the more details that will be decomposed. Like so. Notice that there is no preview, again because of how complicated the algorithm is. The next group of filters we will move on to are the distorts. The first distort filter is the Apply Lens feature, which warps the image around an oval. The next filter, Cartoon Legacy, has all the same options as the first cartoon option, except for clipping. The next filter, Clothify, simulates a cloth texture on top of the image. The sliders Blur X and Blur Y determine the horizontal and vertical stretches of the fibers of the cloth. Azimuth determines the direction of the lighting. Elevation determines the height of the cloth texture. And lastly, depth controls the distance between the bumps and the hollows of the cloth. Like so. The next filter, Gimpressionist, is the most complicated and we will be saving it for later. The filter after that, Photocopy Legacy, has the same features as the regular photocopy, except no clipping options. The next filter after that, the Predator filter, attempts to simulate the heat map from the Predator movies. The next filter, Soft Glow Legacy, does the same thing as the first soft glow option, except you have no clipping features. The next filter, Van Gogh, attempts to simulate Vincent van Gogh's art style by mixing the image with a gradient. The first option, Filter Channel, will determine whether it uses hue, saturation, or brightness to affect the image. The second option, Derivative and Gradient, are nothing more than inverted versions of each other. The third option, Convolution, determines whether you use white noise as a reference point or the image in question as a reference point. The image you choose to use has its lighting points referenced for the blurring and pattern effects the Van Gogh filter applies. Filter length determines either how blurry a blur is or how rough a texture is depending on what you're using. Noise magnitude determines the size and amount of white noise. Integration steps determines how pronounced a gradient effect is on the image. The minimum value determines the minimum lighting or frequency affected, and the maximum value does the opposite. Like so. The less artistic filter, weave, works by weaving a pattern over the image as if it were a blanket. The ribbon width determines how wide each ribbon weaved is. The ribbon spacing determines how far apart each weave is. Shadow darkness applies darkness to make the weavings thicker or thinner. Shadow depth affects how wavy each weave is. Thread length determines how often a texture is repeated across the weave. Thread density determines how much individual threads there are on a weave. And thread intensity is how opaque each thread is. Like so. The reason the GIMP Impressionist option will not be discussed until a later video is because it uses vector graphics as well as the pixel graphics we are using right now. With that out of the way, we are now able to move on to the decor filters. The first one is an add bevel. You are allowed to determine the thickness of the bevel, as well as storing the beveled image as a separate copy, and keep the bump layer generated by the bevel as a non-visible layer beneath the layer you apply it to. Like so. The next filter, Add Border, allows you to add a border around the image rather than a bevel in the image. The border X size determines the width of the left and right edges of the border, and the border Y size determines the height of the top and bottom edges of the border. The border color determines the general border color, while the delta value gives you more shades as you increase it. Like so. The next filter, Coffee Stains, applies random position and random scale coffee stains on the image. You are only allowed to specify the number of stains. The rest is handled by the computer. You can also check whether to darken only or make it impose over the image rather than darken blend. Like so. The filter after coffee stain is Fog, which adds a new layer of fog to the image. You are able to name the layer color the fog, determine the turbulence, which is the spread of the fog clouds, and determine the opacity of the overall layer, like so. The filter after fog is fuzzy border, which makes it fade at the inner edges of the image. The color allows you to determine the color of the border. The border size allows you to determine the thickness of the border. The blur border checkbox will determine whether the fuzzy area is blurred or not. The granularity determines the fuzziness of the border. The Add Shadow checkbox will add a shadow at the inner edges of the image. The shadow weight determines the opacity of the shadow. Work on Copy stores a separate image with the filter applied. And Flatten Image will make all the effects happen in one layer instead of making multiple layers for all the different effects. Like so. The next filter is the Old Photo filter, with the defocus checkmark allowing you to apply a Gaussian blur to the image. The border size will add a thick, fuzzy border. The greater the border size, the greater the thickness. The Sepia option will replace all of your colors with shades of brown. And the Model option will use noise to randomly mark your image with spots. You can also check on to work on Copy, which will store it as a separate image. Like so. Because we have alpha transparency in this image, we are not able to use any of the other decor filters, although we generally would not use them for video game design. Similarly, we will not have much use for the map tools in 2D graphics either. The last category of filters we will talk about are the render filters, which render a pattern over the image. Sadly, the fractals do not always work properly, and we generally don't use them for 2D graphics anyway, so we will skip them and head straight to the noise subfilters. The first subfilter is cell noise, which has a scale function for greater noise value, a shape slider for the thickness of each cell, a rank slider which will determine the nth closest point that each cell references, an iteration slider which determines how many times the noise will be applied, palletize, which fills each cell with a random color, and a seed to determine the distribution of the noise, just like the previous noise filters. Like so. The next filter is Berlin noise, which has an alpha transparency slider, a scale slider, a z-offset slider, and a number of iterations slider, although no seed. Like so. The next filter, plasma, has a turbulence slider which determines the variation of colors, and a seed which changes the distribution of colors. Like so. The next filter, simplex noise, uses scale and iterations to determine simple black and white hexagon patterns. It also has a seed to determine the distribution of the hexagon. Like so. The next filter, simple noise, creates a very thick smoke with independent X and Y scales for the noise, rather than just one scale. The detail level determines how detailed the shading of the smoke is, or how subtle the shading is. The tileable checkbox makes the edges match so that you can make a tile out of it. And the turbulent checkbox makes it look like a storm cloud rather than a traditional smoke cloud. As usual, the seed determines the distribution of lighting in the cloud. The last noise suboption, difference clouds, does not allow you to customize it because it automatically uses the difference feature and the simple noise clouds to render your image for you. Like so. The next render subfield, patterns, uses solid patterns rather than noise-based patterns to render the image. The first option, Bayer matrix, uses a matrix of grayscale squares with subdivisions, meaning that you have more squares to cut it into. X scale, meaning the width of each square, and Y, meaning the height of each square. Rotation allows you to rotate the matrix, but only by 90-degree amounts. The reflect checkbox will reflect the pattern by 180 degrees. The amplitude affects the difference of lighting between each square, and the offset changes the offset of the default values from pure white to whatever tint they now have. The exponent slider determines the overall brightness of all the squares. Finally, the X and Y offsets determine the overall offsets of the pattern, like so. The checkerboard pattern allows you to use only two solid colors, with X and Y scales for the width and height respectively, and the X and Y offsets, like so. The next pattern, diffraction pattern, works by reflecting wavelengths of different colors, so it looks like a pond ripple almost. The frequencies determine the concentration of red, green, and blue waves in the image. The contours determine how curved the red, green, and blue lights are. The sharp edges determines how pronounced the edges of the red, green, and blue waves are. The brightness determines the overall brightness of the image. The scattering determines how far apart the contours are. And the polarization determines the curvature of the overall image, like so. The next filter, grid, divides the image into a grid of squares. The width and height determine the width and height of the squares. The offset X and Y determine the offset of the grid. The line width and line height determine the thickness of the lines between each square. And the line color determines the solid color of the line, like so. The next filter is linear sinusoidal, which allows you to determine the X and Y periods, the X and Y amplitudes, the X and Y phases, the overall angle, the overall offset, which makes the white greater, and the overall exponent, which makes the black greater. You also have X and Y offsets, in addition to rotating the entire pattern. The last option is supersampling, which determines the level of sampling it uses for anti-aliasing, like so. The next filter option is maze, which renders a maze with black walls on a white background. The width and height determine the width and height of the maze. The algorithm type is only one of two and determines how the walls are generated. The tileable checkbox makes the edges match seamlessly so you can use it as a tile. The seed determines the distribution of the walls. The foreground color determines the wall color and the background color determines the color of the rest of the maze, like so. The next filter is sinus, which has nothing to do with noses, but is shorthand for complex sinusoidal. The X and Y scales determine the horizontal and vertical scales of the pattern. Complexity determines how much waves the pattern is made out of. Random seed determines the shape and distribution of the waves. Forced tiling will make the edges match up evenly. And distorted will make the waves uneven. Color 1 determines the inner color, and color 2 determines the outer color. The blend mode can be sinusoidal, linear, or bilinear, which is a mix of the two. A positive exponent will mean color 1 will be more pronounced, while a negative exponent will mean color 2 will be more pronounced. Like so. The next filter is the spiral filter, which can either be linear or a constant distance between each ring, and logarithmic, which means an increasing distance as you exit the center. X and Y determine the position of the origin. Radius determines how thick each ring is. Balance determines the spacing between rings. Strangely, the greater the balance, the lesser the spacing. Rotation determines the angle you start from. And direction determines how you rotate away from the origin. Color 1 determines the color of the rings, and color 2 determines the color of the space between the rings. For a logarithmic spiral, you have a base slider as well, which determines how quickly the spirals increase as you go out. Like so. The legacy checkboard option works entirely different from the normal one, and only allows you to have gray and transparent colors, and also does not allow you to determine width and height individually. It will only scale it in a 1-to-1 aspect ratio. There is also a strange cyclability checkbox, which smushes the checkerboard on the left and top borders, like so. The next filter, CML Explorer, is far too abstract and complicated to be used for digital graphics. So we will instead move on to the Legacy Grid option. This has tile width and tile height, as well as the thickness of the lines, and offset as well. But you could also determine how often these three values intersected, like so. The next filter is Jigsaw, which allows you to determine the amount of horizontal pieces, the amount of vertical pieces, the bevel width, or how beveled the edges of each jigsaw are, and the highlight, which determines the amount of highlight or the brightness of the highlight on the edge of each jigsaw. You can also determine whether the edges of the pieces should be square or curved, like so. Like the CML option earlier, the Cubist option is far too complicated to be used for practical purposes, so we will ignore it. The next filter, Spirograph, is also very complicated and we will not use it for game design graphics. But the filter after that, Circuit, we can use. The two options are Oil Mask Size, which determines how blurry the circuit prints are, and Seed, which determines both how much circuit prints there are and how they are distributed across the image. The No Background option removes the grayish background outside the circuit traces. You can also check Keep Selection, which preserves the selection you are working on before you use the circuit filter. And finally, the Separate Layer checkbox adds a new layer for the circuit to be applied to. The Gfig filter is also far too complicated to use. The next filter is the Lava filter, which has a seed variable for the distribution of the lava pattern, a size variable for the scale of the pattern, a roughness variable for how rough the edges of the pattern are, and a customizable gradient with 3 colors by default to determine the color hues of the lava. You can also tell it to keep the current selection you are working on, store the lava as a separate layer rather than in the layer you're working on, and finally, use the current gradient, which uses whatever gradient you have left in the gradient editor. The next filter is the Line Nova, which can be used to create an anime style attacking background. You can specify the total number of lines, the sharpness of each line, the offset radius, which determines how big the empty part in the middle is, and the randomness, which determines how much variations there are in size between each line, like so. The final filter that we will be going over in this tutorial video is the Sphere Designer. This filter renders a 3D sphere over the original image. By default, you will see the sphere has one texture and two lights. You can create new properties from scratch, duplicate these existing properties, or delete these existing properties. The three property types it will allow you to select from are bump map, light, and solid texture. The texture option below the property type will distort the light if you have a light property, and will apply directly on the sphere if you have the texture selected. Beneath it are two colors, one for the center of the sphere and one for the edges of the sphere. Scale determines how large the texture will be. Turbulence distorts the texture in accordance with a randomly distributed noise. The greater the turbulence, the more noisy it will look. Amount determines how strongly the texture is applied, similar to opacity for 2D shapes. An exponent determines how shiny or how high the value is of the surface. The three transformation options on the right scale it according to the X, Y, and Z, rotate the texture according to the X, Y, and Z amounts, and the position of the texture according to X, Y, and Z amounts. If this is a light, this is determining where exactly the light hits the sphere. If you want to start fresh, you can hit reset, and if you are satisfied with the sphere you have made, you can hit OK to apply it. You can also open existing sphere patterns and save the sphere pattern you are editing. We have now gone over all of the basic filters for GIMP and Photoshop. Although the sheer amount of layer effects and filters I have gone over today may seem very overwhelming and frustrating at first, they make your job a lot easier once you get used to setting them up, because they do most of your work for you and you don't have to draw anything by hand. During next week's tutorial, we will discuss image resolution, the crop tool, and the basic transforms. These will allow us to see the basic difference between vector and raster art, which is the type of art we've been working with so far.